Hello everyone, my name is Anadipti. Today we are going to discuss about random process and classification of random process in probability theory and stochastic process. First, let us see what is meant by random process. What is a random process? A random process, it is also called as a stochastic process. In simple words, a random process is time-varying random signal. Here we can see the definition. A random process is a collection of random variables that change with time. In simple terms, it is a time-varying random signal. There are examples for the random process such as noise signal, message signal in communication, and variations in weather, speech, or music signals. Next, why do we use random process? There are many applications for the random process. So let us see some. We use random process to study signals that change unpredictably with time, such as noise or message signals. We cannot fully know their behavior, only to their statistical properties like average power, variance, etc. can be known. Hence, they are described statistically, not deterministically. And here, random processes have infinite energy because they exist over all the time. So instead of total energy, we study finite energy functions like correlation function and covariance function. Here, correlation function is nothing but it measures how similar the signal is to itself at different times. It is nothing but time shifting like delayed signals, etc. Covariance. It measures how two random variables vary together. This helps us to understand the time domain behavior of random processes. Let us see about random process. Here there is another definition for random process. That is, a random process is a process in which random variable depends upon both time and sample space. Here time is how the variable changes over the time. T and sample space, the random outcome from an experiment. So the random process can be written as x of s comma t or simply x of t. Here we are denoting the random process as capital X of t. Here s represents randomness and t represents time. That means for every random outcome, we get a different signal. That is nothing but function of time. Now let us see different forms of random process. Here first when time is fixed, that is look at a particular instant of time. The random process becomes random variable because only randomness remains. So it becomes as random variable and it is represented as capital X of S comma T1. Here this shows the random value of the process at time T1. Example, noise voltage measured at one instant, but may differ each time we repeat the experiment. Next, when sample space is fixed. Here, we are looking at one particular outcome, that is, in one experiment. When sample space is fixed, it becomes real function of time, and it is represented as capital X of S1, t. This means for one specific experiment S1 how the signal changes over the time. For example, the wave of one realization of a random signal, like one recording of noise. Next, when both time and sample space are fixed, and when both are given, it becomes a constant and it is represented as x of S1, T1. Example, the value of a signal at specific instant in one experiment. Now we have discussed three forms of random process. First one is when time is fixed, and second one is when sample space is fixed, and third one is when both time and sample space are fixed. When time is fixed, it becomes random variable, and when sample space is fixed, it becomes real function, and when both are fixed, it becomes a constant. Now let us see classification of random processes. And random processes can be categorized based on whether time and amplitude of the random variable are continuous or discrete. Accordingly, they are divided into four main types, that is, continuous random process, continuous random sequence, discrete random process, and discrete random sequence. Let us see one by first one is continuous random process. A random process is said to be continuous if both time and random variable are continuous over the entire duration. In this type, the random variable can take any value within a continuous range for all the moments of signals. Continuous random process is nothing but by taking the continuous value. Here we can see the graphical representation, a sample function of continuous random variable. Here taking continuous values means nothing but taking the point values like 0.001, 0.5, 0.002, so on. An example is fluctuation of a noise voltage in an electrical circuit where both time and amplitude vary continuously. Next one is discrete random process. In this random process, random variable take discrete values but time is continuous. The random variable can switch only between certain fixed levels while the time progresses continuously. For example, digital signals that alternates between two discrete levels. Here, it is nothing but a pulse. Here, sample function of a discrete random process is given in a graphical representation. Here we can see that random variable is discrete values and time is continuous. And the third one is continuous random sequence. A random sequence occurs when time is discrete but random variable is continuous. The random signal is defined at specific time intervals, but its amplitude can take any continuous values. It is represented as a set of random variables defined for discrete sampling instances such as pk equals to 0, 1, 2, so on. This type is often used when sampling a continuous signal without quantizing its amplitude. Here to convert from continuous to discrete, we have to perform a sampling method. And in this continuous random sequence, here the time is discrete and random variable is continuous. In graph here we can see in the picture sample function of a continuous random sequence. Here, sampling a continuous signal without quantizing its amplitude is done by taking the discrete time values. Next, the final classification of random process is discrete random sequence. Here, when here it is both time and random variable are discrete, and it is mainly used in digital signal processing. In this, both time and amplitude are sampled. We can see that in figure. Sample function of a discrete random sequence, and here there are multiple levels. So, in discrete random sequence, both time and random variables are discrete. The signal is sampled at discrete time intervals, and the amplitude is also quantized into discrete levels. This process is commonly used in digital signal processing. The amplitude may be represented using two levels or multiple quantized levels depending on application. It is often obtained by both sampling, that is time and amplitude, both sampling and quantizing. So in this we have discussed what is meant by random process, different forms of random process and classification of random process. Different forms of random process, that is when time is fixed, when sample space is fixed, and when both time and sample space is fixed. When time is fixed, it becomes into a random variable, and when sample space is fixed, it becomes real function of time. And when both time and sample space are fixed, it becomes a constant. Next, classification of random process. There are mainly four types. That is, first one is continuous random process, discrete random process, continuous random sequence, discrete random sequence. Coming to continuous random process, here both time and random variable are continuous, and in discrete random process, time is continuous and random variable has discrete values. And continuous random sequence, here time is discrete and random variable is continuous. And the last one is discrete random sequence. In this, the both the time and the random variables are discrete. And we can see the graphical representations for these four in this PPT. Thank you.